Imagine this. You're in your kitchen, stacking clean plates after washing them. Naturally, you place one plate on the other, making a neat stack. And when it's time to grab a plate, you don't reach for the bottom one. You pick the one on top, right? Well, that's exactly how a stack works. In this video, you'll explore the concept of stacks, one of the most important data structures in programming. By the end, you'll know what a stack is, how it operates, and how to use its basic functions. So what exactly is a stack? It's a data structure that works on the last in, first out, or LIFO principle. You've already seen this in action with your plate stack. The last plate you put on the top is the first one you take off. Stacks in programming work precisely like that. But before we go deeper, let's quickly define a linear data structure. This type of data structure has elements arranged in sequential order. Think of it like a line of people waiting to get into a concert. Each person stands in a specific order, one after another. Stacks aren't just a theory, however. They're used all over in programming. For example, when your browser lets you click back to return to the last page you visited, it's using a stack. Or when you're undoing a mistake in a document, same thing. Understanding stacks can help you recognize these patterns in everyday coding. Now let's get into the main operations that make a stack tick. There's push, pop, peek, and isEmpty. They sound simple, but they're also super important for managing data in a stack. Let's break them down. First up is the push operation. This is when you add an item to the top of the stack. Picture adding a plate to your stack of plates. It goes right on top, becoming the new top of the stack. In coding, when you push an item, it becomes the top item in the stack. To see how this works, imagine your stack of plates. Picture an empty stack where you first place plate 1. Then, plate 2 goes on top of plate 1. Finally, you'll add plate 3 on top of them all. As you'll see shortly, the last plate you added, plate 3, will be the first removed in a pop operation. This is how stacks follow the last in, first out principle. Now, what if you need an item? Then you pop it off the stack. The pop operation removes the top item from the stack. Just like grabbing the top plate, the last item you added is the first one to go. This operation usually gives you the removed item as well, so you can use it in your code. Let's return to the stack of plates. You have 3 plates in your stack, plate 3, plate 2, and plate 1. When you pop, plate 3 is removed first, followed by plate 2, and finally plate 1. Now the stack is empty. What if you don't want to remove the top item, but just want to see what's there? That's where the peek or top operation comes in. It lets you take a quick look at the top item without popping it off the stack. It's like glancing at the top plate to check if it's the right one. Let's return to the plates. If you peek when there's only one plate, you'll see plate 1. Now, if you push plate 2 on top and peek, you'll see plate 2. Finally, if you push plate 3, a peek will show that plate 3 is now on top. So with the peek operation, you get to see the top item without making any changes to the stack. In a stack data structure, peeking is useful when you need to know the top or most recent element, but want to keep the stack unchanged. Finally, there's the isEmpty operation. This one's handy when you need to check for any items left in your stack. When you run this operation and the stack is empty, it returns true. If not, it's false. Simple, right? It helps avoid errors, especially when you try to pop or peek at an empty stack. For example, in your plate scenario, you start with an empty stack. After pushing plate 1, the stack is no longer empty. The more plates you push, the more items the stack has. But before that first push, isEmpty would return true, meaning the stack has no elements yet. So, that's a stack in a nutshell. Just remember the last thing in is the first thing out. Elements are pushed onto the top of the stack and popped off from the top, just like how you'd handle a stack of plates. Remember this and you've got the essence of stacks. Keep practicing these concepts because they're foundational in programming, and you'll see them pop up, pun intended, in more advanced topics down the line.